Hi everyone. Today I'll be taking question number 23 from GATE examination 2023. Okay, I'm reading the question. A cobalt nucleus emits a beta particle and is converted to nickel star. Star is defining, that means it is in excited state with angular momentum and parity value 4 positive, which in turn decays to nickel 60 ground state with angular momentum and parity 0 positive by emitting 2 photons in succession. As shown in the figure, which of the following statement is correct? So it is saying like some beta decays some beta decay process is going on, and the cobalt nucleus is converted into nickel, and then nickel is in excited state, so it is now coming back to ground state by emitting 2 photons. So you need to find out which one of the following option is correct. Okay, some transition is there, electric transition and magnetic transition. So for electric and magnetic transition there are some rules, right? So there are some parity selection rules. We should keep that rules in mind for solving this question. For electric transition, it will be minus 1 raised to the power L. L is angular momentum. And for magnetic transition, it will be minus 1 raised to the power L plus 1. Okay, and when L is equals to 1, it will be dipole. For L it's equals to 2, it is quadrupole, and for L is equals to 3, it is octupole. Okay, and so on. So first one is 4 going to 2 without any changes in parity is in electric octupole transition. Okay, so we'll solve this. So the L will vary from J1 J2 negative to J1 plus J2. This is J1 and this is J2. So 4 minus 2 is 2. 2 4 plus 2 is 6. That means L will vary from 2, 3, 4, 5 and 6. Now in the question it is octupole, right? Octupole, as I have told you, octupole is 3. So L is equals to 3. Now you need to find out parity for it. For electric transition, parity is minus 1 raised to the power L, and L is 3. So parity is changing. But in the question, 4 going to 2 without any change in parity. That means this is wrong. Now we have just now proved that this one is wrong. A is wrong. Now going for B, it is 4 going to 2 without any change in parity, magnetic quadrupole. Quadrupole is 2, right? Magnetic quadrupole. Again same, L will vary from 2, 3, 4, 5 and 6. And L is equals to 2 because magnetic quadrupole. And now parity will be minus 1 raised to the power L plus 1, because in quadrupole magnetic transition parity is minus 1 raised to the power L plus 1, and for electric it is minus 1 raised to the power L. So 2 plus 1, it is again minus 1, that means parity is odd, but in the question it is not changing. So this statement is also wrong. This one is also wrong. Now next one is 2 going to 0, electric quadrupole transition. 2 going to 0, electric quadrupole transition. So L will vary from J1 J2 to J1 plus J2. L is equals to 2, right? This is quadrupole. Okay, so parity is For electric transition, minus 1 raised to the power L minus 1 raised to the power 2 is positive. So it is correct because L is 2, electric quadrupole, and parity is not changing. It is correct. So answer is C. But we will solve for D also. 2 going to 0, magnetic quadrupole transition. 2 going to 0, magnetic quadrupole transition. We know our answer is C, but still we are doing it to find out why this D option is wrong. So L is 2. Parity for magnetic transition is minus 1 raised to the power L plus 1. L is 2 minus 1 raised to the power 2 plus 1 minus 1. Parity is changing. That is why this statement is wrong. So answer is C, which we have already found out. Okay. So this is also wrong. So C is the correct answer. I hope all of you understood this question and answer of it. Thank you.